Hello and welcome to another Motion Industries how-to video. My name is Tom Clark, I'm your host, and on today's how-to, we're going to be talking about AEGIS bearing protection rings. And here to help us out, first-time guest of the MiHow2's, Adam Wilworth. Adam, welcome, man. How are you?
Thank you, Tom. Great to be here.
It is great to have you here. Now, I'm kind of excited because normally we don't start things up before our guests actually come on set, but we got a motor cranked up here. I got something that I'm not really quite sure what's going on, but I want to know what we have and what bearing protection rings are, so I'm going to let you kick it off.
Well, Tom, let's first identify where bearing protection rings are used.
Okay.
They're used on motors that have VFDs, which stands for variable frequency drive, and they're used to save energy and control processes throughout most industrial and commercial applications, from motors that are 1 horsepower up to thousands of horsepower. VFDs can save up to 30% in energy consumption, but because of their design, they supply high-frequency pulses to the motor instead of a smooth sine wave. They create shaft voltages and currents, which can cause bearing damage, downtime, and even critical failure. 3
things I hate, so obviously it negatively affects motor reliability.
That's correct, Tom. When the VFD pulses the motor, the incoming voltage is in an unbalanced state, which creates common mode voltages and currents because of the high-frequency switching of the power transistors in the VFD. This causes voltages to be capacitively coupled to the motor's shaft, which then seek a path to ground.
Yeah. Okay. So, now how do we know if this is happening to your motor, though? What have we got to do?
That's a good question, Tom. The best way to see if you may have this problem is to measure the shaft voltage when the system is running, using a high-speed oscilloscope with a shaft voltage probe kit, such as the one from AEGIS, is the best way to see what's happening on the shaft of the motor.
Before we actually do this, what do you say? You put on your PPE, and I'm going to put on mine as well. We've got our safety goggles on, and remember, whatever the job calls for, make sure you're wearing the proper PPE because safety is first. All right, take it away, Adam. Let's go.
Great. Here we have a motor operated by a VFD. We're going to touch the motor's shaft with a shaft voltage probe and look at the display on the oscilloscope.
All right, you do that. I'm going to look. Whoa! Okay, that just went all haywire.
You can see that the voltage is over 35 volts peak to peak, indicating a problem. After the motor warms up, the oil film in the motor's bearing starts to allow discharges which can damage the bearing race, eventually leading to fluting and bearing failure damage.
Yeah. Now I can see it's very obvious right there. That's not going to be good. That's going to be downtime, isn't it?
That is downtime, and very expensive downtime at that. The voltage spikes that you see on the oscilloscope display are very typical of the type of voltage that causes damage in the motor's bearings. When you see the pattern like you have in this bearing, the damage is already occurring.
Okay, so it's already occurring. You know, what are you going to do when you see this pattern happening then?
Well, Tom, providing a path to ground is the simplest approach. We're going to do this with AEGIS U-kits, which are designed to be directly fitted on the motor's end bracket and may be installed in the field by maintenance personnel, in addition to a high-frequency grounding strap which will take that voltage and current all the way from the shaft through the ring to ground. First thing we're going to do is we're going to turn the motor off. And while the motor is slowing down, we're going to assemble the AEGIS bearing protection ring. We're going to select the brackets and attach them to the ring, and they're going to match the holes that we have in the motor end bracket. These need to be drilled and tapped so we can screw the ring on. The next thing we're going to do is we're going to clean the motor shaft, make sure we have a clean metal surface. We're going to clean the motor shaft with a fine grit sandpaper all the way around until you have just a clean, bare metal surface. Okay. The first thing we're going to do is we're going to coat the shaft with this highly conductive colloidal silver shaft coating, which provides a highly conductive surface and helps inhibit corrosion. And then we're going to need to dry it, so Tom, if you don't mind.
Okay. Now, how long is this actually going to take to dry, Adam?
This only takes a couple of minutes.
All right, what's next?
The next thing we're going to do is we're going to install the AEGIS bearing protection ring. Now, the protection ring just slides right over the motor shaft. We're going to match the brackets and the holes, and I'm going to use the Allen wrenches that come with the kit to tighten them onto the motor end bracket. You want the fibers, the conductive microfibers, to touch the coating. And the last screw. All right, we'll just make sure everything's nice and tight. We also want to make sure that this is centered on the shaft.
Now, Adam, once that's tight, we've got to make sure that our motor is back on and running so we can test it again to see if the AEGIS kit has done its job.
That's correct. But one more step, we want to make sure that we also attach the high-frequency AEGIS high-frequency grounding strap so that we have a highly efficient path to ground for these high frequency currents. All right, let's turn it back on.
Now, how long do we have to let the motor go before we're actually ready to test again?
We can test it right away.
Okay.
Because you'll see, if there's shaft voltage on there, you would see it right away.
Okay.
All right, so what we're going to do, and you can watch the oscilloscope, we're going to put the shaft voltage probe right against the shaft like we did before.
Do it now.
Okay, it's touching the shaft.
Go ahead.
There it is.
Touch the
it's
shaft.
touching right
it's
now.
not touching the...
It just looks like it's not because
Wow.
all of that voltage is going from the shaft, through the shaft grounding ring, through this strap directly to ground.
That's amazing. Well, that actually worked.
That's right.
The AEGIS Ring U kit, the AEGIS high-frequency grounding straps. I mean, is that good for any NEMA frame size?
That's right. We sell kits for any NEMA frame size, and even larger motors, we can make an AEGIS shaft grounding ring in any size.
Okay, and what about the silver coating?
The silver coating comes along. You can buy that separately. You can buy everything at Motion, from the shaft grounding rings to the straps to the silver coating. We even have a conductive epoxy, which you can install the ring without drilling and tapping holes into the motor, as long as you remove the paint from the motor's end bracket first.
Okay, what if I want to know about shaft currents or anything, how am I going to look all that stuff up?
To figure all of this out, we have a helpful guide that we call the AEGIS Best Practices Handbook that's available for free from any Motion representative, and it has all the information on shaft currents and how to protect your motor.
And they can get that from Motion if they want to give them a call.
That's correct. That's available from Motion, from any of the Motion reps.
That's awesome. Well, that is an excellent, extremely
All right.
informative demo. I had a good time here today,
Thank you.
Adam.
Thank you very much.
Thank you so much. That was Adam Wilworth. He is from AEGIS, and that's a pretty cool demonstration right there. I like that. Hey, if you have any questions about anything you saw here today, like Adam said, you can get the handbook from your Motion Industries representative, but they can also answer questions about anything you saw on the video. So just contact the one that's closest to you. I know there's a local branch somewhere that you'll be able to reach out to. And also, as you saw, Adam had his PPE on. I wore my safety glasses as well. Whatever the job calls for, you have to make sure you wear the proper PPE. Safety is always number one. And as I always say, number two is checking out more how-to videos with me, Tom Clark, as your host. Or you can also check out Tom's Toolbox as well. Thanks for watching today.